Welcome to Filtration Matters, the regular podcast from BOFA International, a world leader in portable fume and dust extraction. In this series, we'll be exploring how innovations in filtration and system design are helping to improve productivity across multiple industry sectors, including in laser, 3D printing, and electronics. BOFA experts talk about how advances in extraction technology are helping to optimize manufacturing processes and product quality, while at the same time contributing to a clean, healthy working environment. Today we'll be talking to Richard Hurd, a technical sales manager at BOFA, who will be guiding us through the world of laser engraving and cutting. It's a process that's had a significant and positive impact on multiple markets, from the personalisation of Etsy-style jewellery and hobbycraft to serious design and prototyping projects. We'll also be discussing why fume extraction is sometimes overlooked by smaller business users and hobbyists, and why it needs to be on the must-have tick list. So before we dive deep into laser engraving and cutting, perhaps give us an insight into your work at BOFA.
Yeah, so I've been at BOFA now for about 17 years. Through those years, sort of had many different roles in the company. Again, sort of started in the production area, just building some of the systems, and then moved into the R&D department, helped design some of the systems that we still make today. And from there, moved into product management, and then got into the sales departments. Okay,
thanks, Rich. I guess the best place to start is to understand some of the fundamentals about laser engraving and cutting. Where might we find this technology in terms of market sectors?
Yeah, so it's used in a really wide range of applications. I think I'll start by saying how BOFA sort of defines it, because in our company, we talk about laser extraction as a big group, but actually there's subsections within that, one of which is laser engraving. And the way we define that in the company is where the product that's being lasered actually stays stationary and the laser head then moves over it, whereas in the opposite of that would be laser coding, where the laser is stationary and the product moves past it. But it's used in loads of different applications now and loads of different markets. I mean, just to reel off a couple here, education sector, pretty much every school has got a laser engraver in it now. Trophies, personalization of goods. I think, as you mentioned in the intro, sort of Etsy businesses as well. So pretty popular at Christmas doing those sort of personalized gifts. Even marketing, branding of souvenirs, things like that, and even onto things like jewelry and fashion. So engraving of jewelry, rings, getting your names engraved on them, but also fashion. So actually, a lot of the jeans that you see in the shop now that look, I think they call it the stonewash look. Quite a lot of those are actually done with lasers now. They actually distress the jeans using the laser.
And I guess at the other end of the scale, then you're also talking about companies who are using lasers on a more industrial scale for cutting and engraving. Would that be right?
Yeah, that would be it. So what I referred to there is, I wouldn't say hobbyist, because some of it's very serious and, good business. But yeah, the laser cutting is a sort of step up there. And to be honest, some of those systems go into the sort of, they're the size of a room. And that's sort of outside the realms of what we supply to today. But yeah, you will find laser cutting machines in heavy duty automotive plants and things like that. They cut complete car doors out using lasers nowadays.
Okay, so maybe now we can just talk a little about the technology. I mean, we hear a lot about CO2 systems and fiber lasers. What's the difference? And is there a go-to technology for engraving and cutting?
Yeah, there's a couple that spring to mind straight away. So there's the CO2 and the fiber type lasers, and they're common across a few different sort of laser markets. But the two that we see, the most common one that we see in laser engraving is CO2, and that's used for the majority of substrates or applications. So that's a laser that's suitable for use with wood, glass, plastics, things like that. And then really when we think fiber, although it can laser other substrates, we typically default to thinking that that's going to be on a metal application. It's worth sort of just talking about the technologies very quickly though, and saying that, lasers or laser engravers specifically become very accessible to the general public now. And it only takes a quick search on eBay and you'll find some for around the £400 mark. But obviously, there's more professional systems that go up to the 30,000 or even higher price point.
So I guess this brings us to the question of the fume and particulate generated by laser engraving and cutting. And self-evidently, I assume this depends on the material being worked.
We definitely do have to take into consideration what substrate is being lasered when we're speccing up a fume extraction system for a customer. But just before we sort of go a bit deeper into that, just sort of thinking back to what I said earlier about the fact some of these lasers are accessible now to the public via eBay. So some of these systems, they may not have the appropriate safety interlocks. So it's always worth going to a sort of reputable company to purchase these. And that company should then actually be able to provide guidance on fume extraction, at least pointing you towards the correct sort of companies to look at and speak to. Hopefully you'll be directed to BOFA, and from there, we'll be put onto our application specialists who would look at your application, talk about the sort of materials that you're lasering, and then work with the sales team to select the appropriate extraction unit for you. So just to talk about some of those applications quickly, if we took out a customer who was lasering some form of plastic, then we'd be looking at some of the decomposition products from that plastic, seeing what gases are going to be given off, cross-referencing that to our carbon suppliers' information to see if it's compatible with that particular substrate.
So now will be a good time to think about what a BOFA system looks like and how easy it is to plug into a laser setup.
Yeah, so we've got a wide range of systems within BOFA now that are suitable for the laser engraving market. Obviously, over the years, that range has grown, but they range from anything as small as a unit similar to the sort of size of a bedside table, up to the size of a sort of medium-sized wardrobe, effectively. But really, the majority of systems that we sell are in the sort of middle range here, so sort of just over waist height, and about 400 or 500 millimeters square. So not a huge system at all. And the way we decide which system is correct for that laser engraver is typically by referencing the bed size. And by bed size, that's a sort of laserable, if that's a word, size area where the substrate could be placed. And the reason that's something that we use is it helps, from that information, we can then figure out how much airflow is needed to evacuate that chamber and draw good extraction from the process. In terms of connectivity, depending on the sort of sophistication of the laser, we have, the R&D department within BOFA can work with our customers to allow interface between the laser and the extractor. And that interface typically operates to allow the extractor to start automatically when the laser does, but it also gives a signal back from the extractor, to the laser to let it know that it's functioning well and it has no errors. So you kind of have this sort of safety feedback loop here where you don't forget to turn the extractor on because it's done for you, and then we let you know back into the laser, hey, this extractor's working well, continue use.
Okay, so I guess the point to underline here is why do we need it? What is it actually doing? What's its function, both from an environment point of view and perhaps from an equipment point of view? What's the value of it?
Yeah, there's a couple different angles there as you picked up on. So the first one I always go to is actually looking at the process itself. So if we allow the process to take place, i.e. the laser is now ablating some of the surface that the customer's working on, that laser cabinet is going to be filling up with fume, so a mixture of particulate and gas. That's going to get in the way of the laser optics. It's going to reduce the quality of the mark. It's also going to, potentially get onto the laser optics, and then it can damage them. So all in all, just not good for the product itself, but also not good for the product that you're producing with the laser. So you're going to get a lesser mark there. But secondary, as you touched on the environmental bit there, and also a bit of operator safety here, that you don't want to be sat next to a laser all day that's producing these sort of fume mixtures. That there could be some pretty nasty stuff coming off some of the substrates that you may have selected. So dealing with those with a fume extraction system is definitely an intelligent way to go. Just touch on the filtration side of things that's within our systems. We start off with a particulate filter, so that takes out some of the larger media. And then we move on to a combined filter, and that combined filter has two elements in it. The first one is a HEPA element, so a high efficiency particulate air filter, and that takes out a very high percentage of very, very small particulate that could be harmful to humans if inhaled. And then above that, there's a carbon layer which deals with some of the smells and gases that are given off with certain processes. And then out the back of the system should be very clean air. It's always worth getting in touch with our applications guys here at BOFA, where with the MSDS sheet from the product, or the substrate, so I should say, that you're looking to process. Because as I said before, those guys on that team can take a look at that and determine if the filter set that we're looking to provide is compatible with the media that you're lasering, and if not, they can then look at alternative medias that we may have in our offering.
So laser is a fantastic and flexible technology applicable to lots of different applications. So what are some of the things you've seen relatively recently that you thought, oh, there you go, that's a really interesting use of the technology?
Well, I can actually talk about that on a bit of a personal level here, Phil, so don't judge me too much. But at home during lockdown, I had a marine fish tank. So it's quite a sort of scientific experiment looking after one of those. But in the bottom of the filtration area, I needed to create a baffle. So actually, we have a laser engraver here at BOFA that we use to test different substrates on. And I was able to get one of the R&D guys to draw me up a pattern and actually laser that out myself. So not necessarily in the market, but useful for me. And another example is, again, don't judge, but I've got a few Lego sets at home that, the sort of larger sets that have the Ferrari cars and things like that. And I wanted to hang those on the wall. And again, a quick drawing on a system in R&D, laser that out, screw it to the wall, and now the car's nicely mounted there. So not necessarily sort of industry examples, but definitely a couple of examples where laser engraving has helped me personally. And also, obviously, aside from my examples I gave, laser used across, as I said earlier, a wide range of applications. I touched on fashion earlier. Some people have bespoke chest sets created using laser engraving. And I've personally visited a couple architect companies in London that actually use their laser engraver to make some of the 3D style models that you see of some of the project work they've got coming up. So yeah, really, really diverse set of applications. I kind of feel like if you owned a laser engraver, you'd find 1,000 different ways to use it.
So finally, Rich, if our listeners want to find out a bit more about lasering and the extraction technology they might need, where's the best place to go?
So I think obviously you can first of all come to our website and take a look at some of the systems that we provide and some of the information we also provide on that website. Another thing is quite good to do is sign up to our academy. So one of my colleagues, and actually the person that runs the academy, is one of the applications guys himself. So great place to get a bit of information there as well. And then thirdly, if it looks like one of our systems is something that you need to talk about in any more detail, then obviously through our website, we've got a live chat function. You can put a quick inquiry on there, and then whoever receives that inquiry within the company will direct your comments to the right person, and away we go.
Thanks, Rich. Our guest today has been Richard Hurd. Many thanks for guiding us through the fascinating world of laser engraving and cutting.
Thanks, Phil. We'll speak again soon, I hope.
Thanks for listening. If you want to find out more about BOFA and the benefits of filtration and fume extraction, visit bofainternational.com, where you'll find lots of sector-specific information. You can also catch up on all our podcast content by visiting bofainternational.com/podcast.